For the first set of examples in this segment, we'll look at how to express numbers in standard form. In example 22, let's do part A first. We'll follow the key points mentioned in the previous segment. First, let's move the decimal point such that the number is between 0 and less than 10. So for part A, the decimal point moves to the left behind 3. Next, we count the number of places that this decimal point moved. Since the decimal point moved left, we can expect the index of 10 to be positive. Since we moved 3 places to the left, the value of the index of 10 is 3, hence 10 to the power of 3. We just need to multiply this value with the first value we have established, and that will give us 3.9629 times 10 to the power of 3. For part B, we can follow the same steps. The decimal point moves left from behind the last digit 0, 5 places right behind 8. That makes the index of 10 to be 5 and hence 10 to the power of 5. The standard form can be written as 8.60000 times 10 to the power of 5. In the Cambridge O-Level syllabus, it is required to keep your final value or answers in 3 significant figures. Hence, for part A, the answer is 3.96 times 10 to the power of 3 in 3 significant figures. And for part B, the answer would be 8.60 times 10 to the power of 5 in 3 significant figures. In the next example, we will explore standard form with negative index. In part A of example 23, we move the decimal point 4 places to the right, stopping between 6 and 4. This gives 6.47 times 10 to the power of minus 4. Part B may seem confusing at first glance because it looks like it is in standard form. But do remember that for a number to be in standard form, the first number needs to be between 0 and 10. So in this case, we still need to move the decimal points to the back of the first digit 9 and add the place values to the index of 10. This value can be written as 9.45784 times 10 to the power of minus 8. And don't forget to leave your answers in 3 significant figures. In the next example, we will deal with the special names of some of these powers of 10. For part A of example 24, Pico is in the order of 10 to the power of minus 12. This means that we are required to leave the answer in the order of 10 to the power of minus 12. To do so, we will need to move the decimal place of 3.84 further left by 2 places, giving us 0.0384 times 10 to the power of minus 12. This means that 3.84 times 10 to the power of minus 10 liters is 0.0384 picoliters. For part B, the storage capacity of 2 terabytes in standard form is 2.0 times 10 to the power of 12. And the file size of each document in standard form is 125 times 10 to the power of 3, which can be written as 1.25 times 10 to the power of 5. Hence, the number of documents that can be saved will be 2.0 times 10 to the power of 12 divided by 1.25 times 10 to the power of 5, and evaluating that will give us 1.6 times 10 to the power of 7 number of documents. Here are some calculator examples for you to try. These are the answers to all 3 parts of example 25. Did you get it? Most of the calculators are able to calculate a string of values linked by various operations. So, you do not have to worry too much on having to do some evaluation before using your calculator. However, it is always good to check if your inputs are correct. You should do this by checking what you have typed and also redoing this quickly again. Calculator proficiency is critical in exams, as you should not be figuring things out on the go. There are some questions that are structured differently. Let's have a look at this particular question. So in example 26, the first obvious thing to do is to input the respective standard forms into this expression. Using your calculator, simply input the values carefully and you will get 1.64 times 10 to the power of minus 2. Questions can also be asked in the form of a word problem. Let's take a look at example 27. A large pipe has a radius of 7.2 times 10 to the power of 2 millimeters. A small tube has a diameter of 16 times 10 to the power of minus 3 millimeters. Calculate and express in standard form the radius of the small tube in part 1 and the ratio of the radius of the large pipe to the radius of the small tube in part 2. So for part 1, the radius of the small tube can be easily found by dividing the diameter by 2, giving us this. And the answer is 8 times 10 to the power of minus 3 millimeters. For part 2, the ratio can be found simply by letting the radius of the large pipe be over the radius of the small tube, like this. We can separately evaluate the values and the powers of 10 in the same step next. And the answer would be 9 times 10 to the power of 4. It's time to try some questions on your own. Want to learn more? I'll see you in the next video.